today we're doing skill 2, which is NS2 conveniently. So unlike yesterday and the day before, where we were doing NS1 with adding and subtracting rational numbers, NS2 is multiplying and dividing rational numbers. So let's start with the first one. Evaluate each expression if the following: f equals negative 15, g equals 5, and h equals negative 45. When we have letters and values, and we know we have to plug those in, if we look at our problem ahead of time, what is that called? What is it called when we have to plug numbers in? Think about in school. Think about when your teacher's missing. Oh, we're going to substitute. So this is substitution. So we're going to substitute these values for the letters. So let's start with the first one. We're going to substitute negative 15 minus negative 45. Remember, the parentheses are only to separate these two symbols, these two signs. They do not mean to multiply here. Be careful of that. And then we have divided by 10. So now we have to kind of throw it back to the last review, and we are talking about subtracting. What do we do when we see subtraction? Additive, good. Inverse. So now we have an addition problem, but with a negative and a positive number. So what do we need to do? What's our rule from our Math Maniac? We're going to subtract the absolute values. Great. So that's going to get us to 30. Divided by 10. What is 30 divided by 10? 3. Right. So let's try the next one. I'm going to try to make this one a little harder for you. So what I want you to do is where this says g minus 5, I want you to make this 5 into an 8. And then we're going to try this problem. I think you can handle it. So let's start with substitution. We have g, which is 5, minus 8 divided by a negative 1. Okay. So can we take away 8 from 5? Sure we can. You're now in 7th grade. But we are going to get a negative number, because we got to go past the 0. Okay, we're going to get a negative 3 divided by a negative 1. So now let's remember we're talking about our multiplication and division rules. We have a negative 3 divided by a negative 1. If you think about that trick, when you have a negative and a negative, they end up giving you a positive. So what's 3 divided by 1? Good, 3. So both of our answers end up being positive 3. Go ahead and read the next problem, and then we will go over it. The equation A times B equals C is given. So this is the information that we already know. Given this information, or that equation, complete the 4 equations below. So we're looking to solve all of those. Down here it says replace the question marks with the values in the expression B. You may use an expression more than once. So we're looking to fill them in with A's, B's, or C's. So like we talked about last week, all of our rules with adding and subtracting, multiplying and dividing, it doesn't matter if we're using values, like we did over here, with actual integers and rational numbers, or if we're using letters. As long as we know our rules and we understand what those rules are telling us, then everything is the same. So let's talk about those rules. So for multiplying or dividing, we have 2 rules. First rule, what if the signs are the same? So for example, -4 times a -4. So if the signs are the same, like a negative times a negative, our answer is going to be good, positive. So think about in third grade, a +4 times a +4 is a +16. So two signs that are the same are going to get you a positive. So what if they are different signs? For example, -4 times 3. So we're going to do our multiplication. 4 times 3 is 12. But we have completely different signs. So when we have one negative, our answer is going to be negative. Great. So now we're going to use these rules to help us solve the equations at the top. So we have a -a times something is going to get us a +c. So let's look at our rules. Which one of our two rules is going to get us a positive answer? A positive product. Good, a negative. So if we already used A and we already used C, okay, we have to use a -b. So this answer is -b. A -a times a -b is going to equal a +c. Good. So let's try the next one. This one's a little more challenging because we're missing both of our first two letters. But we already know we used our C. So if we're keeping in order, we have to use an A and a B. And we know that our product, our answer, has to be negative. So look at that rule. What is it telling us? One of the numbers, or one of the letters in this situation, has to be negative. But do they both have to be negative? No, only one. So let's just do -A. We're going to do -A times, is B going to be positive or negative? Think about our rule. Positive is going to equal a -c. Good. Now, what if we switch those around? Could we switch around and make it a +A times a -b? Sure we could, because it's still the same rule. And what happens when you switch around multiplication, if you switch the numbers around? What property is that? It's the commutative property, just like addition. Does not matter which order you put your numbers in. All right, let's move on to division. Same rules, just looks a little different. So we have something divided by a -b equals A. Well, first of all, we know which letter we're going to use. We're going to use the letter C. Yeah, it's the the letter we haven't used yet. But our quotient here, our answer, is a positive or negative? It's a positive. So let's look at our two rules. Which one is going to get us a positive? The first one. Good. So that means that both of our values have to be negative. So this is going to be a -c. So go ahead and try the last one and see if you can get it. We know we have to use which letters? We already used A. So we're going to use a B divided by a C. But our quotient has to be negative again. So what has to happen? One of these has to be negative. Doesn't matter where you put the negative. You tell me. Could it be a negative, or we'll say a positive B divided by a -c? Sure, because remember, one negative is being referred to as the entire fraction. Good. So we're going to use these rules that we just practiced to solve the problems at the bottom. All right, so we're going to look at our next problem. We're going to read it together, but I need you to use the rules from the top two sections, and you're going to work with the partner sitting next to you. So let's read it together. A teacher assigns 4 points for a correct answer, -1 points for an incorrect answer, and 0 points for leaving the question unanswered. Sounds like my class. What is the score for a student who has 23 correct answers, 2 incorrect, and 1 unanswered? So I hope, first of all, when I was reading that, what should you have been doing? Circling information and pulling it out. Good. So we have 4 points for correct, -1 point for incorrect, and 0 points for unanswered. Now let's see what you did with your partner. Let's start off one at a time. 4 points for a correct answer. So we have 4 points for a correct answer. Well, how many correct answers did this student get? He or she received 23 correct. So if we're trying to say for every single question they got correct, they get 4 points, we could add 4 points plus 4 points plus 4 points, which is repeated addition, which is really called what? Good multiplication. So let's just multiply that by 23. So let's solve 23 times 4. What's 4 times 3? 12. 4 times 2, 8, plus 1. 9. So he or she received 92 points just for their correct answers. But they did have some incorrect answers. So they get -1 point, that's harsh, for getting answers incorrect. But I'd rather you try them. How many did they get incorrect? 2. We're going to multiply again. Now let's remember our multiplication rules. We have a negative times a positive is a negative. So 1 times 2 is 2. Last one. We have for leaving it blank, 0 points times 1. Anything times 0 is 0. Great. So if we know that they got 92 correct points plus -2 points plus 0, what are we going to do to figure out the overall score? Well, we need to combine it, which means adding. So think about this as 92 minus 2. What is 92 minus 2? 90. So this person scored a total of 90 points on their test. So now that you check over your work, see what you missed. And now I want you to go and do this last box. And I want you to read this section and stop at A with your same partner. Go ahead. All right, so let's look at this problem. It says, what are the most likely values of point A and B? And we're going to convert each fraction to a decimal first. So what led you to that decision? So lots of little questions in here. And we're going to start one at a time. So remember that both the NS1 and the NS2 standards, not only do you need to know the standards of adding and subtracting, multiplying and dividing, all those rules, but you also have to be able to prove it on a number line. So here's our friend, the number line. So let's try this together. Just A. All right, so really what we're doing is we are converting each fraction to a decimal. So hopefully you did that first. So let's work down here. This is A. So let's use our rules from above because we have some negatives. Remember, the numerator is the dividend. The denominator's trying to knock on the door. What do? We got a decimal, 0. How many times does 20 go into 70? 3 times. 3 times 20 is 60. Subtract, we get 10. Add another 0, bring it down. How many times does 20 go into 100? Exactly 5. Good. But we have to remember, what did we start with? It was a negative 7/20. So what's our answer going to be? Negative 35/100. So let's see on our number line if that makes sense. Should we be down here? Are we in the negatives? Is it about halfway, a little less than halfway past? Sure. It probably should be a little closer up here. Okay, so let's see if B is in the right place. So if we have 3 divided by 25, we need to add our decimal, 0. How many times does 25 go into 30? Once. 25. We have 5 remaining. Bring down a 0. 25 goes into 50 2 times. Do we need to keep going? No? Why not? Because we know that this is going to get us exactly to 50. Good. So then this answer is going to be 12 hundredths. So let's look at our number line. B is a lot closer to 0 than it is to 1. So does that make sense? Yeah, it should make sense. I think this one's at a pretty good spot. Good. So I want you to do B completely by yourself. And I want you to convert them into decimals. And I want you to plot those on the number line with stars. So plot an A star and a B star by yourself.